Yo, what up? It's your boy, Mr. E, and today we're going to be talking about modeling, adding, and subtracting fractions.
Sean, John, Calvin Klein, Donna, Karen's fashion line, Valentino, Wyatt.
No, not quite that type of modeling, but we are going to use some fractions and they're going to show off what they can do. Now, when it comes to modeling fractions, I know a lot of my students, and usually it's my smarter students, are like, Mr. E, I don't like modeling. This is so easy. I don't need to do this. But this is something important for you to learn. And this is honestly questions on the big test that a lot of my smarter students miss because they go too fast. So make sure we're paying attention, writing down these notes, and following along. Let's take a look at a problem. So we've got 1/3 plus 3/4. We could easily, use the numbers, add them up, find a common denominator, but we could also do it visually. So let's bring in two different types of models, okay? On the left, we have a square that is cut into thirds, and on the right, we have a square that's cut into fourths. So if I wanted to represent 1/3, what I would need to do is I would need to shade in one of these three rectangles. Okay, I think we could all agree that that means 1/3. Now, if I wanted to represent 3/4, I have 4 here. I'm gonna have to shade in 4 of these rectangles to give me 3/4. So now I have 1/3 and 3/4, but I need to add them together. Now, the way they are right now, they're not in equal parts. So we're going to have to put them in equal parts. If you notice, I have my horizontal lines, they're in red, and I have my vertical lines, they're in blue. So let's go ahead and let's put vertical lines on the first one. So we're going to cut these into fourths. Okay. And we're going to add the vertical or the horizontal lines to the second one. So we're going to cut these into thirds. Now that we've done this, we have equal parts, and this is a lot easier to add together. So if I wanted to add these together, I have 1, 2, 3, 4 out of 12. So 4/12 plus 1, 2, 3, 4, 5, 6, 7, 8, 9/12. And if I add those two together, I'm going to get 13/12. Now, this is an improper fraction, so I would like to change that into a mixed number. If I take away 12 from the top to give me a whole number, that would give me 1 in the numerator and 12 in the denominator, which makes sense. If I were to move over 3 of the shaded in green squares from the left rectangle to the right rectangle, I would have 1/12 remaining and one that's completely shaded in, okay? So that's an example where we are adding them. Let's look at one where we are subtracting them. So we have a new fraction, 1/2 minus 2/5. So let's bring those rectangles in, and we're going to start looking at what we're going to be shading in, okay? So the first number is 1/2. So all I need to do is I need to shade in one of the two rectangles, okay? I think we can all agree this represents 1/2. And then 2/5, we would just need to shade in 2 of the 5 rectangles, okay? And I think we can again agree that this would represent 2/5, okay? But again, their parts are not equal. So what we need to do is we need to go back and we need to add the vertical and horizontal lines. So the blue lines are vertical, we're cutting them into fifths, okay? So 1, 2, 3, 4. I do apologize, those are not very even, but that's how Mr. E does it sometimes. I'm not always very even, okay? And then the next one, we would just cut in half. So once again, we would go back and we would start counting how many rectangles are shaded in. So 1, 2, 3, 4, 5 out of the 10 rectangles are shaded in, okay? And on here we have 1, 2, 3, 4 of the 10 rectangles shaded in. Now we can subtract these. So 5 minus 4 would give us 1/10, which makes sense. If I were to cross off, so I have 4/10 right here, if I cross off 1, 2, 3, 4, I only have one more remaining, and that would be 1/10. Okay. So this is typically the way that I like to model fractions. But one thing that we're going to find is when we do our independent practice, when we do our CFAs, snapshots, or even the STAR test, a lot of people model fractions differently. And it's up to us to be able to look at a modeling fraction problem and be able to figure out what they're asking us to do. Okay. So let's take a look at a couple of example problems. So in this first problem, it says the shaded part of the model represents a fraction. Another, another fraction was subtracted from the first fraction. Which expression does the model represent? So we have a model right here, and we are trying to figure out what what expression it's representing. Which, remember, an expression is a number sentence without an equal sign. Okay, so when I look at this, okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 shaded in, and we have 12, 13, 14, 15. So we have 11 shaded in out of 15. Okay, so when I'm looking at my problem, and G doesn't have that fraction, and neither does H. Okay, so we can kind of take those out of the way. Okay. Now, what I notice is that 1, 2, 3, 4, 5, 6 out of the 15 are shaded in. So it's looking like if we're subtracting, we're going to need to put a subtraction symbol and then 6 out of 15. Okay. So now you might be thinking, oh, Mr. E, we don't have an option where we can do that. But that's where we're wrong. We have an option where we could simplify this fraction. What I noticed right away is both of these numbers are divisible by 2, or by 3, sorry, by 3 to give us 2/5. So this model would represent 11/15 minus 2/5, which would be J. Okay. And it makes sense because this is crossing out 1, 2 of my 5 columns. So 2 out of the 5 columns are crossed out. So that's equivalent to 6/15. Okay. So that's an example of subtracting problem. Let's take a look at a adding problem. Okay, Vanna, maybe Vanna White from Jeopardy, used the fraction strips shown to help her determine the difference between 5/6 and 1/4. What is the difference between 5/6 and 1/4? Well, I said we're going to be doing an adding one. Apologize about that.
It's too late to apologize.
It's another subtracting one, but it is modeling fractions. Okay, so I'm trying to see what 5/6 minus 1/4 is. Now, we could really, really easily just subtract those two numbers and find our answer, but we can also use what we have here, okay? So I'm going to shade in 5/6 really quickly, okay? So we've got 1, 2, 3, 4, 5 shaded in rectangles out of the 6, okay? So that's 5/6, okay? And then what I'm going to be doing is I'm going to be taking away 1/4. So let's use a different color, and we're going to say this is 1/4. Okay. So something I noticed though is that that just kind of gives me like a half of a fraction. So what I'm going to do is I'm going to take this 1/4. I'm going to draw all the way down the line. Okay. Because I know that this is no longer going to be here. Okay. But I also want to draw a line from where my 5/6 stopped and draw that down. Okay. Now it looks like this fraction in the middle won't work, but this fraction on the bottom does work. And what we're left with is here. Okay. So if I shade in at the bottom, 1, 2, 3, 4, 5, 6, 7. These are the twelfths. So that would give me 7/12. And that would be our correct answer. And we could even double check it by using our adding and subtracting fractions. So 5/6 minus 1/4. The common denominator would be 12. To get to 12, we would multiply 2 over 2. To get to 12 over here, we'd multiply 3 over 3. And that would get us 10. And that would get us 3. When we subtract this, that will give us 7/12. So Modeling fractions is a great visual way to work with fractions, okay? I know that some of us might think, you know what, it's just easier to stack the numbers up and use those numbers, and that is possibly true, but we should also be capable of doing it where we can do it visually as well. I hope this video was helpful. I hope you know fractions are tough, and this is going to be something we do need to practice a lot, and we will get it. We'll work on it, and we'll get this stuff, okay? All right, hopefully this video was helpful. We love you, we miss you, and we'll see you later. Bye.